Today, we are pulling back the curtain on the invisible rules that pretty much run our digital lives. From streaming a movie to hopping on a video call, there's this incredibly complex dance of data happening behind the scenes. And the people who choreograph that dance, well, they're planning some massive new moves. Let's dive in.
I mean, have you ever stopped to think about it? You connect to a new Wi-Fi network, you plug in an Ethernet cable, and everything just works. It feels like magic, right? But it's not magic. It's the result of some absolutely incredible and often overlooked engineering.
So meet the unsung heroes of our connected world, the IEEE 802 Standards Committee. These are the folks who make sure all our different gadgets can speak the same digital language. And right now, they're not just tweaking the rules, they're writing a whole new chapter. Okay, first up, let's get to know the group that quietly, behind the scenes, makes our modern lives possible.
So the IEEE 802 Committee is basically this global team of experts, and their whole job is to develop the technical rulebook for almost all of our local networking. We're talking about Ethernet, the wired backbone of the internet, and 802.11, which you and I just call Wi-Fi. Their most crucial job is making sure all these different pieces of tech can work together, seamlessly.
As our world gets more and more complex, our networks have to do more than just keep up. It's not enough anymore to just be fast. They need to be incredibly precise, totally reliable, especially when the stakes are, well, life or death. And this brings us to a really key innovation: time-sensitive networking, or TSN. The goal here sounds simple, but it is revolutionary: to make sure that data arrives not just fast, but exactly when it's supposed to.
Okay, think of it this way. A traditional network is kind of like the regular mail. Your package will probably get there, but you don't know the exact time. A time-sensitive network, on the other hand, is like a guaranteed signed-for courier service. It promises that every single packet of data will arrive within a very precise window. No late packets, no excuses. So why is this such a huge deal? Well, in a factory, it means all the machinery can be controlled with perfect split-second timing. For autonomous cars, it means a signal to brake is never, ever delayed. And for things like high-quality media streaming or remote healthcare, it means that data that's basically useless if it arrives late doesn't get sent at all, which saves precious bandwidth. Of course, raw speed still really matters. And the next jump for wired Ethernet is, well, it's just staggering. The IEEE is working on standards for speeds up to 1.6 terabits per second. That is a mind-boggling amount of bandwidth, and it's being designed to handle everything from the core of the internet right down to our most data-hungry gadgets. But, it's not all about just getting faster. The future of networking is also about getting a whole lot more intelligent and efficient, sometimes in ways that you really might not expect. And this just goes to show that progress isn't always about adding more. For things like the sensors in a car or in a factory, you don't need blistering speed, you need efficiency. And that's where single-pair Ethernet comes in. It uses just one single pair of wires for both data and power. That dramatically cuts down on weight, cost, and complexity. It's a perfect example of a smarter, not just a faster solution. So that's the wired world. But believe it or not, the very same engineers are giving our wireless networks a new superpower. And this is one that sounds like it's straight out of science fiction. Just think about your Wi-Fi router for a second. Its job is to send and receive data, right? But what if those same radio waves could be used for something else entirely? What if they could actually perceive the world around them? This is the incredible idea behind a new standard called Wi-Fi sensing. It uses the radio frequency energy that's already bouncing around the room from your Wi-Fi network to detect motion. By analyzing how those signals get disturbed, it can figure out the position, the speed, and even just the presence of a person or an object. And the best part? No new hardware is needed. The potential here is just amazing. Imagine a home security system that can detect an intruder without any cameras, or an elder care monitor that knows if someone has fallen over. The technology is so sensitive. At higher frequencies, it can even detect the tiny motion of a person's chest to monitor their breathing. This is a complete reimagining of what Wi-Fi can even do. Now, all of these new wireless technologies, from the faster Wi-Fi to this new sensing stuff, they create a new challenge. There's only so much radio spectrum to go around. And let me tell you, the airwaves are getting crowded. So the problem is that radio spectrum is a finite resource. They're not making any more of it. The solution, then, is to get much, much smarter about how different technologies share that space. It's called coexistence, and you can think of it like teaching a bunch of people who all speak different languages how to politely take turns in a conversation in a very crowded room.
A perfect example of this is what's happening with Wi-Fi and 5G. See, Wi-Fi has always used what's called unlicensed spectrum. It's free for anyone to use. 5G has typically used the licensed spectrum that cell carriers pay big bucks for. But now, to boost performance, both of them want to share that same unlicensed space. And that means we need new rules of the road to make sure everyone plays fair.
Another really clever solution is a technology called Ultra-Wideband. As Dr. James Gill puts it, it works by spreading its signal out over a huge range of frequencies, but at a very, very low power. So to other devices, it's basically like a whisper in a crowded room. It's there, but it's so quiet that it doesn't interrupt the main conversations, which lets it reuse that spectrum super efficiently. So when you put all of these different pieces together, the precision, the speed, the smarts, and this new awareness, a really clear picture of our digital future starts to take shape. So what's the big takeaway here? Your network is getting more precise, which is absolutely vital for things like self-driving cars. It's getting massively faster, paving the way for things like truly flawless virtual reality. It's becoming more efficient, with smarter, lighter wiring and everything from factories to our homes. It's becoming more aware, with Wi-Fi that can literally sense the world around it. And finally, it's becoming more collaborative, as all our devices learn to share the airwaves. All of this is the foundation for the next huge wave of innovation, and it leaves us with a really fascinating question. As our world becomes connected in ways we can't even predict yet, what new technologies are going to pop up that will need their own set of rules next? What will these engineers have to figure out then?